Alright, so welcome back to 30. It is day 22, and it's also week 4, the final week of the 30 scripting challenge. Now, obviously, there are not 8 days in a week, but for some reason it classified it as a week. But this is probably going to be the hardest week, seeing how week 1 is really easy and now week 4 is getting to a lot harder stuff. But the first day of week 4 is an upgrade system, and it mentioned to use a tower to upgrade it, but I'm gonna take the upgrade system I'm gonna take it at a little bit of a different approach here. So when you're making an upgrade system, it's best that you classify it as a service that different parts of your code, of your program, of your game can use. Because let's say you have a system where your tower can upgrade, but then you can also have other parts of your game that can upgrade. So they wanted us to use a tower, but we're going to have it be for everything. So let's say you wanted a way to upgrade this damage part here, or you wanted to upgrade the amount of drops that came out here, or upgrade just the NPCs level in general, right? Instead of creating upgrade logic for each different part of the code that tailor to the specific enemy, you can create one global upgrade place where all of these different parts of your code can move to then upgrade themselves, and we can apply a bunch of helper functions to assist it there. So I'm going to make a module script inside of our services here, and this will be called upgrade service, right? And this can also be used as a utility as well, or it could be used as a service. Now you could put it in modules, or you could keep it in services, or put it in utilities, wherever, but we're going to use this kind of like a service, but actually not. I don't even know why I did that. It's more of a utility than a service, but whatever. So when we're getting into week 4, I want to introduce the topic of strict right here, and the way you'd indicate it is 2 comments at the top of your code, followed by an exclamation mark, and then see how it autofills here with strict, native, no link, no check, optimized, non-strict, right? We're going to want to enable strict here. And what that means is if any of the parameters we pass in are not what we want them to be, it'll throw an error, basically. So everything in the code has to be strict, which is hence the name. So this is pretty much, we're going to want this to be driven through metadata to kind of just show modularity and allow our upgrade service to expand to other aspects of code. So in this case, the first thing I want to actually set up is it's a type, and types allow you to define certain behaviors for an object. And we want to run this function, or this utility or whatever, called export type. And this will allow, in this case, the other aspects of our code to access this data, because we want this to carry through. It's it'll let us define a reusable data structure that we're going to use for our upgrades. In this case, it's simply going to be called, because we're in upgrade service, we can just call it upgrade definitions here. And when you're making types, it's assigned to a table where you put all of your types in. So when we're upgrading, we want a maximum level. We need a limit to set our thing to. And if you don't want any levels, you can use math.huge, right? But that's going to be a little more difficult when we're working with actual objects that need a physical upgrade, right? So we want a max level, so put that in here, and then you want to put a colon to represent the type, and then in this case it is a number. I'll put a comma to go on to the next one, right? We want a max level because it'll allow us to move on. It'll allow us to keep repeating until that certain point, that max level, when we know that they've reached the max level and there's no other data that exists for them beyond the max level. As well as that, we kind of want the levels themselves, right? We want a way to store all of the levels that are going to pass in, right? So in this levels table here, it must have a number. In this case, that number has to represent the level that they're going on here. And that number is basically just going to carry the data for that level. So our cost, in this case, every upgrade will have to have a cost, whether that be a string or a table filled with items, if you're crafting an upgrade or whatever, anything like that, right? And we would, most of the time, our cost would either be a number or a item, or a string that we can access to upgrade something. But usually the cost itself, that is a string, which will be referencing a number, which is like a cost in like gold or gems or whatever. Alright, and we put a question mark here because not all of the upgrades have to be a string. They could be a string, but the question mark here indicates that it doesn't have to be a string. Now, we also need a callback, a required callback practically, so that way we know what our code's going to do after an upgrade has been completed. So, in the sense of a tower defense game, when we want to upgrade a tower, the input is the player clicks the upgrade button and sends over like 100 gold to the server to upgrade tower A from level 1 to level 2. So our cost here would be 100 gold for level 2, and then we'd also put in a callback, which would be applied after our upgrade. So we would call it like apply callback or after upgrade. And when we're upgrading a tower, we first change its model to the upgraded version, and we also change its level to the new level. So we're simply just going to put that inside of our apply. It'll be an instance, which, kind of has to be an instance, but we'll put it with a lowercase I so we don't get confused with the library, the instance library, and then the, next level. So we can put in the new level that they're upgrading to, which is number. And because this is a function, we would indicate that with this arrow that outputs. Now, this arrow means it's going to output something. If the table is empty, it's not going to return anything, but if you want, you could have it return like a table that has models inside of it. You would put the table that would say model, and then it would return a table with models. That's what the type would be. And that's basically for our upgrade definitions. Now, I also want to make one more type, which is the context of our upgrade. And the context object will pretty much hold all of the data we need to process an upgrade. So things like instances, like the object we're upgrading, the current level, which is the number, the numeric level that we're at right now, the definition, basically, because that would be the upgrade definition, and that would guide its behavior in a way. And we'll also put like an optional for the player, because our player can be connected to upgrades such as a local access tower, which means that tower is only upgradable by you. So we can pass in the player for that as well. Now, when we're passing the context of our upgrade as one single object, it kind of avoids fattening up functions or loading them in a way, which can overall make fixing and debugging code a lot easier. Which is why I'll be doing that actually, is for when we get to the debugging phase. So we do the same thing. Export type, because we want this to be accessed multiple times. In this case, like I said, it'll be called the upgrade context. And that's the thing. Instance, that's the instance we want to use, but whatever. And there we go. It would look exactly like this. Pretty simple. Okay, let's move on to more of the servicing part and the utility here. The first thing that we want to do is run a validation to make sure that the upgrade definition contains the actual structure, because we don't want to move on to the actual upgrade unless our definition actually has the required data we need to upgrade to whatever we're trying to upgrade to. So we could put this as a local function because we only want this function to be accessed inside our code, or you could just say function upgrade service _, validate definition. That's one way to do it, or you could say local function. Both of these work almost the same way. This underscore represents internalization, while a local function means that it will only be accessed locally. So we'll use the local function for now. So this is called the validate definition. Because it's local, I like to put it in camel case sometimes, but I'm still trying to work on getting a consistent name scheme. And just jump around both, which is not good. You should pick a solid name scheme, so coding actual larger scripts won't be a pain. And this validate definition function, it's literally just going to validate that the upgrade definition contains that required structure. That's as the name says. So we just want to pass in the definition here, and because we have our upgrade definition type here, we can just put in upgrade the definition here for our type check. Now, in our valid definition, we just check through all of this. So in our upgrade definition, we have two things. We have a max level and our levels. So the first thing to check is if the max level is a number. So if type of, and in this case, we use type of to determine if the value we put in, the type of the value we put in is equal to a certain type, or to check whatever type it is. So the type of our definition, max level, see how the autofills here because that's what's in our type. If that is not equal to a number, the lowercase n, that means that they didn't structure their type correctly. And we're just simply going to toss an error. So we'll say like, no max level, or no valid max level. And this is a great way to catch errors, because if your max level isn't a number, then what's it going to upgrade to? A part, like, it means a number to move on, basically. And the second one is our levels, which is a table, so we can loop through it, right? So we can just say for the level, and then the data of that level in the definition dot levels loop. Now, here you could put it in pairs, because we kind of do want our levels to be in somewhat of an order, but if it can figure out what's wrong, that means everything's wrong. If one part of the structure is wrong, then all parts of the structure are wrong, because it can't run everything if one part of it is wrong. So you could put it in pairs, or not, or you could put it in iterator pairs. I wouldn't encourage it unless you do it. So anyways, let's run our if type of thing. So if the type of the level here is not equal to a number, in this case our level, it's a number, so when we run our for level data, this is our level right here, and this is our data. So if it's not a number, we're just going to throw an error saying that the level has to be a number. And we could say the same thing here, max level has to be a number. Okay, we can now do it for our data. So if data, and then we have our apply thing here. Now, when we're also doing this question mark, it also just means it's optional, meaning it's strict, won't basically murder you to death if it's not there. So if our data dot apply, which is the callback function to apply after we're done upgrading, is equal to parentheses is equal to nil, and also I need to take the parentheses out. If data applies to nil, then we're going to toss another error. Now, if you wanted to be more precise with the errors, you can just tell it what level has the error. So you could just say, if this were a professional place where I'd be working for someone and they want this to be professional, I would put in upgrade service level 5 is missing their callback function. But you could just say level, just do something like this, right? A nice simple error message that you say. So level 5 is missing the callback function. But I would make this a lot more detailed if it was an actual professional workplace that I was doing, that I was working in. And that's a nice validation function, right? As long as we know that our structure is correct, we can actually move on to updating our object. Now, we have the definition structure, right? Now, we need our context structure, right? So, kind of lied there. So, to validate our context, same thing. All of our context is instance, current level definition, and if they passed in a player or not. So, we can simply just make local function, validate context. And then we'll just do ctx for short, for context, and pass in our upgrade context type. So, same thing, instance, current level, definition, and if there is a player. But actually, we probably won't even do that. So, if the context.instance is equal to nil, that means there's no instance passed. That means you're simply going to, I don't know if we should put a return in here, because should I have it return? I don't know. We'll decide that later. The same thing. So if the context.definition is equal to nil, then whatever, we'll have it return or not return or set a value. How did I misspell then? What the heck? Wait, there's two thens. What the heck? And then if the context dot current level is less than 0, then we're gonna put, so I'll just reminder, put something here, there, and then come back to it later. And then if we wanted to, if we were using a return, I'd put a return at the bottom here too for whenever we're gonna call the validate context, which will probably be when we get the actual message to run an update command. But now that we have our validation helper functions, we can now determine the next level of data, or we could just return failure reasons in case, well actually in a way this error message is kind of like a return, so whatever, we'll figure it out. So we want to determine the next level of data, right? So I'm going to say get next level data, and then pass in the context for our next upgrade. So we'll say that local next level value will equal to the current level, but plus 1. So we know that's our next level. Now check if that next level value is greater than our max level, then we're going to basically just say that we're already at max level. So in this case, we can just return like a nil statement here, and like a comment or like a string thing at max level. So in this case, if you're upgrading something and you're already at level 5 and they try to upgrade it again, you could like have it visually displayed to the player that they're already at the max level. So you could pass in like a callback thing here or whatever. But this was just saying like at max level, just a simple return. For when we're on whatever side we're receiving the upgrade from, we can check if the data is equal to nil or not, right? So now we can do for level data. So say local level data, and that's going to be our contexts dot definitions dot levels, and then we'll put in our next level value. If we have our level data, or if we don't actually, if it's doesn't exist, same thing. We can return a nil value for whoever is receiving it and say, I don't know, there's no data for the next level, something like that. And if these go all well, we'll just return the level data and an empty string. Okay, so why are you underscored? What? Oh, that's weird. I don't even know why that's there. I mean, it shouldn't affect the code. It's just a type error. I don't know. See if it'll crash all the code or not. Okay, yeah, I think I'll probably put a return here, because when we validate the context, I do want it to return true if it's valid or false if it's not. So like a return false here, and then a statement like how we're doing in the get lexicon data. So I'm gonna say like instance missing, because this is when instance is equal to nil. And I can also return a false here because the definition is missing. Say like definition missing, and then if the current level is 0, so current level is negative or whatever. Say like current level is negative, but if not, we'll just return true without an error message. Because then when we're like moving on to actually like applying the upgrade and we run the validate context, we'll have a false or true return going on. Okay, now we can move on to verifying the actual cost to make sure that our upgrade can run. So I can say function upgrade service dot check cost here. Now, this isn't a utility, it's not a helper function, it's simply a way to determine whether a player can meet the upgrade cost, or if the server itself can meet the upgrade costs. So obviously I want to put in our upgrade context, and also like a table filled with all of the costs that the player has to meet here. So first of all, if there isn't, and also I kind of want this to return a boolean, because when we're checking the cost, we just need to make sure if it's valid or not. So when we have a cost table, right, that's just the table that we're going to check through for all the costs to make sure if they meet it or not. So if the cost table is empty, or if there is no cost table, then automatically they should be able to accept it, because there's no reason why. Yeah, I'm gonna toss an error message in there as well. Yeah, I guess I have to add more. So I'm just gonna copy this general idea where we return our thing and then also an error statement if there is one. But if the cost table exists, or if it's empty, right, then by default there's no cost, so they can upgrade it anyways. We now need to make sure that we have an actual player, because costs require a player to deduct from, or in this case the server to deduct from if the server has a pool to deduct from. So we could use ctext.player, context.player, or like whatever the server passes in value. So if the context.player doesn't exist, meaning there's no player to deduct from, we're simply going to do the same thing. We're going to return false, saying they can't upgrade, and we can put in an error message saying cannot apply the cost, player missing. But I would definitely make this a lot more cleaner and informative for when I'm actually working for here. But this is basically a way to say if our player doesn't exist, we can't deduct from anything, and therefore we can't run the rest of the code. Okay, now there's one other thing we can use for deducting stuff from the player. Now if it was a server, you'd simply just put another value, call it is server deduction, and skip all of this, but I'm not going to do that. I'm focusing on the player, because a player is where you usually run a lot of upgrade systems, right? Now, there's two ways that we can get the player's values that we want to deduct from. There is the player's leader stats, or there's the player's data store. In this case, or actually just in general, it'd be easier to access the player's leader stats, because the leader stats are automatically saved when the player leaves the game. So deducting them here and then saving it will also be really easy. Or just getting their store in general if stuff that's being deducted is not on the leader stats. But this is a fast way to do it. We can simply grab the stats folder, and it would just be the ctext.player, find first child, leader stats. That's the name of the leader stats folder where we keep all of our data. And also, once again, if our leader stats folder is missing, we want to throw another error message. saying the player doesn't have a leader stats folder. Because when we get our player leader stats folder, we're going to want to deduct the costs from whatever stats they have in the leader stats that match. So that's what we're going to do. We're going to make sure that all of the resources, whatever, are present in the leader stats and they have enough of it. So for the currency name, and then the required amount to upgrade inside of our cost table here. And once again, cost table can be put in pairs if you want it to check in order properly, or just do it from however it does it. I might make an in-depth video explaining why you would use pairs, or nothing, because the difference is really beneficial when you need them, but it's also okay to use it without them. Right. Oh, we're gonna get our stat object here, so we'll say local stat object. Right, that's going to be us finding the actual currency that we want to deduct from. So in our cost table, it would be gems, and then I don't know, one, and we'll deduct one from that. Right. So if we can't find the state object inside of the leader stats, we need to return another error saying missing currency, or lowercase m, missing currency. And if you wanted to, you could just attach the currency name. And that's probably what I would do, but I'd make the prints more nicer. Okay, I'll stop saying that. Hopefully, if someone's reviewing this video, they're never have to hire me or not. Just know, I'll make the prints look nice. Really nice. Anyways, now we're going to have to check if our stat object is less than the required amount. Then, we're going to, once again, return false, because they can't for the upgrade, and we're going to say not enough, the currency name, right? Not enough gems, not enough XP, whatever, right? Why is this still, okay, whatever. Anyways, if we do get everything properly, we can return a true statement, meaning everything matches. And I can put in a string here, so that way all of the code paths here will return a boolean or a string. So when we're passing in our initial return as well as our error message, it allows for debugging to become really easy. Now, when you're working with studios, right, and other game developers, not every game developer is going to be a programmer. Meaning, if you're on a vacation for a week and you can't access your computer, and there is an error that is in your code, like there's a bug in your code somewhere, or something like that, right? Or when you're when your team is trying to set up new data, meaning they're trying to make a new addition to a shop, like adding a new item in their shop. If the player wants to purchase that item, you're not going to have to manually code in the item for them. They can simply just add in that item as well as any values for the item, and your code will tell it if it's missing any items. So in this case, the player is missing. Okay, maybe I didn't add any player value. Well, that's the wrong variable. What am I doing? Like up here, right? Instance is missing. Okay, let's add the instance, which in this case is that golden shovel, right? Definition is missing. Okay, let's put the definition of the shovel: a golden shovel that digs really quickly. Current level is negative. Okay, let's put the current level to 1, because that's the first level of the golden shovel, right? It'll allow other people to correct their own mistakes without having to beg a programmer to get online. Okay, we now need a function outside to apply the cost. So we'll just run, upgrade service dot apply cost. Everything's gonna need our context, by the way, and the cost, because we want to apply everything. So if you want this to look pretty, you can attach that thing there to make it look nice. So this is simply just going to deduct the cost after our upgrade validation succeeds, meaning it's all clear. We can now go on ahead and upgrade. Once again, if our cost table is equal to nil, then we're literally just going to return it. Because if there's no cost table, what are we deducting from? If the player doesn't exist, the player doesn't return, because we're not throwing a different error message. If the cost table is equal to nil, or the player is actually, if both are equal to nil, whatever, right? Well, if one's nil, then we're just going to return it anyways. So if the cost table is nil, we're going to return. Or if the player doesn't exist, so if the context dot player is equal to nil, right? If either or of these don't exist, we're just going to return it anyways. Because if we were to put player after cost table and cost table doesn't exist, it would return it and restart. If it does exist but player doesn't exist, it'll return it anyways and it'll restart, right? But in this case, we're not going to toss an error message because we're still on the actual main synchronous upgrade function. This is all kind of the actions that lead up to that. So now we have our like check the top done, or grab the leader stats folder. We're just gonna copy this, but I'm gonna delete this portion here. I'm gonna delete all of that because we aren't returning anything here. This is simply just applying the concept to return anything other than like a success thing, but that doesn't really matter because all of our success has been calculated already. Now we're looping through all the currencies. So I literally could just copy this or do it again one more time. So for underscore currency name required amount in cost table to stat object and find first child currency name. If stat object is not equal to nil, then we're gonna set the value of it to minus equal the required amount. Now something I'd recommend is when you're going through loops here, you could just set this to be a value. Now if you don't know what value it is, like you're unsure, you can put value base and it gives you all of the things. Okay, apparently that's not a thing. What? Well, if it was a number value, alright, whatever, just ignore that. In Visual Studio Code, you would get a autocomplete or autocorrect feature that you could use here to resolve type errors. Alright, anyways, now we can do our main synchronous, like the core upgrade logic, right? So it'll connect our validation, connect the cost checking, applying the cost. It'll just connect everything together. So this is what our like outside code will activate. So function upgrade service dot upgrade, and all we want is the upgrade context here. So here we would simply just run our validation, and as we put in the update validation portion here, we have our is valid and our reason. So I can simply do the same thing here, and I can say if it is valid and the error string. Okay, I did that type check wrong, or not type, the thing. Types are really cool. Type notation's really nice, but I friggin' like have a problem for some reason. Maybe because I'm recording this like so late and I need to go to sleep, but who knows. Anyways, we have our is valid, that's our boolean, and the reason why we filled the error message, right? That would be simply just running the validate context with context provided. And if our is valid is equal to false, or if not is valid, then we're going to return false and our fail reason. Or if you wanted to, you could just return the is valid because it's false, it's a boolean. Now I can validate a definition, so we could run that validate definition thing, pass in. Now we actually didn't return anything in our validate definition, right? No, we didn't. Okay, we just have error messages there. Okay, that's our validation portion, basically. So we can move on to the retrieval. So say local level data, and then our second reason. So I could put reason 2, or I could just put the reason, or fail reason 2 will equal to the get next level data. Put our context in. If the level data is equal to nil, then we're going to return false. Pass in our reason 2, meaning we cannot upgrade because of this issue that happened. Now we can validate our costs. So we can say local cost check. Well, actually, we'll probably put the cost reason as well, or the fail reason 3 will equal to the upgrade service dot check costs. Now, other parts of the code can run this, or other scripts can run this too if they want to check the cost. And we can put the level data dot cost here. So if our cost check, if not cost check, that's equal to false, we'll return false. And our fail reason 3. Moving on, we can now apply the cost. So we could say upgrade service dot apply cost in the context and the level data cost, because in our level data we have the cost here, right? And after our validation has occurred, we can now run the apply portion, which is after the upgrade, whatever you want to happen, our callback. Right, so we could pass in the instance as well as the current level plus 1, because that is what we have defined up here. And now, because we need to make sure our return scheme is consistent, we'll return true, meaning the upgrade was successful, and a message saying upgrade successful. And we can do the same thing here where it'll return a boolean and a string. And that would wrap out the synchronous part, right? Now, we can also make an asynchronous part that would wrap up the upgrade function in a task.spawn, so it can happen without blocking our main script. So if you had a tower defense system that upgraded our tower, we wouldn't want to block the entire code until the tower has been upgraded, meaning we don't want to have it wait until the model has been copied over, the data has been copied over, etc. We can have it run asynchronously, which means like parallel and stuff. Not true parallel, but I don't want to talk about that right in this video because parallel Lua is cool, but not all easily just discussable right now. So we're simply just going to call this upgrade service, but async upgrade, and this will upgrade it asynchronously. So we can return a task.spawn function here, which task.spawn has it run asynchronously, has the followed code run asynchronously, or we can put the success and then our error message here to be the upgrade service dot upgrade, passing in our context here, and if the success is equal to false, so if not success, then we're going to, because this is asynchronously, we're simply just going to put a warn instead of an error message here, and say like async upgrade failed, and then you could pass in your message, put the message in there, and that's basically the upgrade service module. Okay, I fixed it. I just made a custom like defined level data type here that I put for this, and then added it over here. But now this one isn't fixed either, so say if stat object one is a value base and stat object is not equal to no. Now it's saying value not found in class value base. What? It's supposed to. Why is it not? Okay, there we go. Fix it. Let's put it as an int or an value, because those are the two numerical data loaders. Okay, so let me go make an example loader here, as well as an example like upgrade database that we can use. So let's go on ahead and make a folder, and I'm gonna call the folder week 4. And in this folder, I'm going to make a server script that's just gonna act as the loader. Not a scrolling frame. Oh my god, it's gonna act as our loader. So I'll just call this upgrade server. Right here now, in here I'm gonna put a module script that I'm just gonna have all of the data in. So this will be like our upgrade definition, right? And once again, I want to introduce the idea of using strict coding to make sure that all of our types are actually correct. And this module is, I think, it would be considered as a metadata only module, and I'll just describe how the part would upgrade. So you would have one of these for all of the towers you'd have in a tower defense game. So, I could call it flamethrower. In this case, I'll just call it the part upgrade definition, because I don't actually have a tower to upgrade. I don't have like the golden minigun from Tower Defense Simulator. I don't really have that. Anyways, right, we just store all the upgrade data in here. So obviously we want our max level to be 5, because it's fine with TDS, and we'll just make a table for all of our levels, and each entry will correspond to correspond to what applications that level should do, like specific that level. So 1, right, that's going to equal to this table, so level 1, cost, right? We want that to be gems will equal like 1, because that's the currency that we're going to use. Can describe that it needs 1 gem to upgrade, right? Now, our apply. This is what happens when the upgrade is completed. So, in this case, you would copy the model over to your new tower if it was an actual tower. I don't have tower, so we're just going to use a block, right? Whoa, what is going on? We'll pass in instance, new level, because this is never going to happen, and say instance dot size will equal vector3.new, and we'll choose like a 3x3x3 cube, so we'll actually be able to see it. Not instance with the capital I, instance of lowercase I. This one right here. No, don't do that. Okay, and then our color. So instance dot color will equal to color3 dot from RGB. You know what? Let's friggin' make it like 255, 200, 200. So like a yellow cube or whatever, right? There. And that's going to be an example of what our upgrade definitions would look like. But for tower, once again, your instance would just be let's open the documentation for vector 3, whatever, right? It would be the model that you're going to clone over from replicate storage and replace it with the current model and send that model back to replicated storage. There's no object pooling. It's a nice way to save your memory usage. Instead of constantly creating new instances and destroying them, you'd keep them in a pool and pull them out of each other, right? Alright, now back to, this is just going to be our example. We're just going to put a proximity prompt on it. So we'll get the upgrade definitions. So upgrade service, and then we'll say local part definition will equal to require script dot part upgrade definition. And anyways, I'm gonna make a part real quickly, so we'll say local the part, and I'll just make sure to anchor it. The name, we'll call it upgrade part, just like that. So the part instance will be workspace.upgrade part, and I for some reason put a backslash in it. Workspace.upgrade part. Now we'll make a prompt, so local prompt will equal to instance.new proximity prompt, and we'll say prompt.parent will equal to the part instance. And I'll also make one for the level, so local level int will equal to the instance.new int value, and then we'll say level int.name will equal to level, and that's it. We'll show its value easier because we'll add it by one at a time. So now we'll just make a function to attempt the upgrade. So say local function attempt upgrade, and we're gonna call this after the function prompt's triggered, so we'll pass the player in too. So I'll say prompt dot triggered connect function and pass in the, or no, we want to call the attempt upgrade thing here. So connect attempt upgrade. So the player should automatically be passed here. Now, at the context, so we're going to construct it right here by pulling it out of the database. And in this case, you just access your definitions wherever you want to upgrade the part. So we'd say instance will equal to the part instance right here at the current level, not rotation curve key. Oh my goodness. The current level will equal to the level int value, and then we'll say the definition will equal to the part definition, and the player will equal to the player, just like that. Nice and simple. For context, now we're going to grab our success and our message, kind of like a p-call here basically, but a little less advanced. Call upgrade service.upgrade, pass in the context here, and we're going to check if our success, then we're going to set the level int.value to plus equal 1, and you could put whatever extra details you want, so I'll just put a printer that says upgraded. If not, we're simply just going to say print upgrade failed, and then the error message that you want to pass in. And that's it. We're good to go. You can also reference other things in here too that you want to utilize, but that should be good to go. So we can hop into the game and go over to our parts here, where it'll say, I probably should have this say upgrade. So now if I click on it, I'm missing, oh, it's because my gems is lowercase, that's why. But now see here how it threw an error, which was good, because gems is indeed not uppercase, so we'll just put you all in lowercase, just like that. And that threw an error. That's pretty good. Let's go back here. Okay, now we actually have an error in 87. So we should probably say stat object dot value, not stat object. That's something that you should catch on here. So local stat object. Stat object. Alright, and put that check there to make sure that it is a numerical value that we can decrement. And now it's saying I do not have enough gems, though I clearly have 9,630 gems. So let's debug here, and we can backtrack a little bit. So our success, it's called from this upgrade function, right? So let's go over to the upgrade and check what might be the issue. And we can also run asynchronous upgrade too if we want to. Alright, so in our upgrade, it's saying not enough gems. So the currency here has to be check cost. So let's go look at our check cost here. Alright, that means our required. So let's print out the stat object.value and the required amount to make sure that they're actually getting the data that they need. So let's go over here and run it. So here we go, 9,630 and 1. So 9,630 is not less than 1. So this shouldn't be running. It's supposed to group. I just Googled it. They have higher priority than our statements. That's why. Okay, there we go. See, it upgraded to that new color. And I can click it again, and it's upgraded twice, and I'm actually losing more gems. I upgrade it again, and I lost more gems, so it's now level 3. Click it again, it's level 4. I've lost one more gem. Now the final level is level 5, and I cannot upgrade it anymore because it is at maximum level. And if we were to leave the game and rejoin, then the thing would reset. Now, if you want your upgrades to stay permanently, like to save on player data, you can make a new table inside the player's profile called upgrades. And for each item that has its own upgrade series, you can store its current level in it. So then, when you're running your part upgrade, you would check right here the player's data. So instead of the current level being level int dot value, you would look in the player's profile, find the actual thing we want to upgrade, and get its level from there. But anyways, that is simply how the upgrade system is going to look like. You can use this for many different components of games, whether that be a tower defense game, that instead of also being able to upgrade towers, you could upgrade gadgets or gears. You can upgrade anything. And this system will create a constant valid upgrade system where all you need to do is pass in this area right here. And you can even customize it even further. This is a really nice building block that you can work off of. And just because I want it to look a little nicer, let's say prompt action text will equal to upgrade. And that's it. All done. Now over here by the checkpoint system from a long time ago and our NPC states guy, I can now upgrade this square to max level. And this could symbolize anything that you want to upgrade in the game. And it's max level, so it won't upgrade any further. That is the first portion of week 4, right? The upgrades. It's not exactly a tower we're upgrading, but it's still a solid upgrade system nonetheless. Okay, that's it. Yeah,